Chapter 6, Section 1, Example 1. Suppose the value of an investment I was $4,350 in 2004. If the value of the investment increases 6% per year, and T is in years since 2004, first, find an equation to represent the investment, and second, find the average value of the investment from 2004 to 2010. For part A, in order to find an equation to represent the investment, we're looking for a growth equation that has yearly growth. So it'll look like this. I equals 4,350 times 1.06 to the t. The $4,350 is our initial value. The 1.06 represents the 6% increase per year, and again t is in years since 2004. Now, we want to find the average value of the investment from 2004 to 2010. This is a 6-year span, and since the t values are measured since 2004, our integral will be from 0 to 6, which looks like this. We have the integral from 0 to 6, which represents the 6 years of our investment. And we have to remember that since we're finding the average value, we need to multiply by 1 over b minus a, or 1/6. Once you compute this in your calculator, you get that the average value of the investment is $5,207.35. Let's look at another example. Suppose that over the last 100 years, the yearly consumption of oil has increased exponentially at a rate of 4% per year. Assume this trend continues and that the oil consumption in 1910 was 175,000 gallons. During which year was the actual consumption closest to the average consumption? So we're looking over the last 100 years from 1910 to 2010. We have an initial value of 175,000 and we're increasing exponentially at a rate of 4% per year. So the first thing we want to do is calculate the average value over the last 100 years. That looks like this. So our interval, again, is from 0 to 100. Our initial amount is 175,000. And the rest of our equation is e to the 0.04t, because again, this is an exponentially increasing function. We remember to divide by the length of the interval, and we get that the average consumption was 2,344,919. Now, we want to know during which year was the actual consumption closest to this average consumption. Remember, the general form of our equation looks like this. P of t equals 175,000 e to the 0.04t. That's our general exponential growth equation for this particular problem. And we want to know during which year, which is t, will this equal 2,344,919. When we set them equal, we want to solve for t. So the first step is to divide both sides by 175,000. So we get 13.3995 equals e to the 0.04t. Now that we have the term with t isolated, we can use natural logs to get that t down. We take the natural log of both sides of our equation, and we remember that when you take the natural log, the power will come down out front. We also remember that the natural log of e is just 1. So the natural log of 13.3995 will equal 0.04t. So if we divide both sides by 0.04, we get t equals 64.88. Well, time is in years, so that's years since we started measuring. Remember, we started measuring the consumption in 1910, so we add this number to 1910, and we get 1974.88. So that means that during 1974 is when we actually equaled that 2,344,919 gallons of oil. So that's the year when the actual consumption was closest to the average consumption.